Hey guys, today we're going to talk about how you can use different aftermarket batteries with your Traxxas Slash 4x4 and also the Traxxas ID charger system. Now, some reasons that you may want to use aftermarket batteries is that perhaps you have other RC vehicles that use a specific connector type. For instance, I have this battery here that has the XT60 style connector. I use this for one of my RC boats. Now, the Traxxas batteries themselves are very nice. I haven't had any issues using them. However, they tend to run a little bit more expensive. But I mean, part of that's understandable because you're paying for the brand name. However, these batteries come with their own proprietary TRX style connector. And these have the integrated balancing leads inside, whereas typically aftermarket batteries will have a separate balancing port that you use with your charger. Now, one of the nice features with the Traxxas ID chargers is that they do offer support. They have separate balancing leads here. These are typically capped, but if you remove the caps, then you gain access. And this can support 2S and 3S batteries. So the system, at least using the standard Traxxas ID charger, can support aftermarket batteries. The main challenge is batteries that you purchase will most likely come with a Dean style connector, which is this guy here, or it may come with an XT60 or XT30, which is this circular style connector here. So how can you use these with your Slash? Well, the simplest solution is just purchasing an adapter. So this is an example adapter, and this is a Dean's connector to the TRX connector. And for the battery connections, these are female connectors, so you want to make sure you purchase the right side. But this adapter will simply plug in like so, and there you go. You're pretty much good to go just using a simple adapter. The only cons with really using an adapter is depending on the quality of the adapter and the solder connections inside, it could create additional resistance in your battery connection. And basically what that could lead to is additional heat buildup on the connectors or possibly voltage sag coming from your battery to the ESC. But that's a pretty simple solution. They also make, this is one that I have, and this is a XT60 to TRX adapter. So for batteries that I want to be able to use, like this one is mainly for my RC boat. If I want to use this on my Slash, then I can simply connect the adapter and then I'm good to go. So if you have another RC vehicle that you're already using a specific connector for, then I would recommend keeping that connector on and then just using an adapter. However, if you're not going to be using, for instance, I don't have any vehicles at the moment that use the Dean style connector, so you can simply buy a set of the TRX female connectors. Now, Traxxas doesn't officially sell these, so you have to purchase these from other vendors, and typically they'll come in packs that have both the male and female mating kits. So there's a technique for soldering these connectors onto a battery, and we'll go over that real quick. So I'll just give you an example of how you can remove this connector, solder on the replacement TRX connector, and then at the end we'll also go over how to connect this to your charger and program the charger with the balance leads. Now, before we get into soldering, I just want to give a quick caution. LiPo batteries can be very volatile and potentially dangerous if not stored or used correctly. So when you're purchasing aftermarket batteries, I would recommend a reputable brand that is well reviewed. Otherwise, I mean, you could take a chance just from buying a cheap LiPo battery, you may end up getting what you pay for. So although you don't necessarily have to spend the money to buy the Traxxas power cells, I would recommend to at least purchase something of decent quality. Now this is a brand that I recently purchased, which is Z. I honestly haven't had these long enough to give an accurate review, so I do not necessarily endorse this brand. I probably won't be able to give an opinion on that for another couple months of use, but so far they're available on Amazon and they seem pretty decently reviewed, so I'm going to be trying those out. But again, please do your own research and be cautious, and make sure that you always store and maintain your batteries properly. Alright, so the tools that you'll need in order to solder your own connectors is, of course, a soldering iron. It's just a small hobby grade soldering iron that I have because I don't use it for too much heavy duty stuff, but mainly battery connectors and some other small connections. So on this unit, since it's a smaller unit, I'll have to turn the temperature setting or the power setting all the way up pretty much in order to get a good result. I recommend also having a pair of soldering hands. These make it really more easy to hold the connections and solder in place. Otherwise, having a second person available may be helpful if you're planning on doing this yourself. And then, of course, you'll need your solder material. So this is a solder that I have that is 63% tin and 37% lead, and it also has a 2.2% flux content. The main important thing is that you do usually want a tin lead mixture, and you want a flux content as well. Now I also have separately a little canister of flux that I use just to help the connections go together and not burn the solder. And then of course you will need your female TRX connector, and note that these are keyed positive and negative. And then you will need your blade connectors as well. And important to note that there's a specific orientation of these connectors. One side, at least for the brand that I have, is labeled B, which I assume stands for bottom, because this is the top face of the connector. And you'll notice that one end on the top side has an indent, and then on the bottom side it has a protrusion. Also, these little marks basically indicate the point where you're not supposed to apply solder past, so you want to make sure that your solder is just on the tip of that connector. So we got these ready to go. Our soldering iron is heating up, and then I also do have some heat shrink material just to cover any exposed connections. I have a container of different sizes, but usually for this wire it ends up being the yellow one that fits the best. So otherwise you can color code it red and black. And then of course you'll need a pair of snips to cut your wires. So we'll go ahead and get into this. Now, a word of caution that I do recommend: when you're cutting the wires for the first time, make sure you only cut one wire at a time. Do not cut both wires at the same time. You will short circuit the battery across your metal cutting tool. So what I recommend, and again to be very careful when doing this, is do not expose both positive and negative leads at the same time. A tip for that: just cut one lead at a time, and I leave the opposite end in the existing connector until we have this fully connected in the connector, so that way they are not exposed. So once you cut it, you will need to strip it back just a little bit. You just want to remove the sheathing from the end of the wire. So there we go, we have our exposed wire. So typically what I'll do, I'll bunch these together. I take my soldering or my flux paste, I'll just dip the end in there. And then we can go ahead and get this into our soldering hand. Now the next step is we want to tin our wire. That helps the connection go together more easily. So you want to make sure that your soldering tip is clean. You can clean this with flux as well, and then we will apply a little bit of solder to our soldering iron, and then I typically will just transfer that onto the connector or the wire lead itself. Hopefully these angles coming through okay. You don't need to apply too much, but you just kind of want to solidify the wire lead here. So that way you don't have to apply as much solder when you're connecting it to the connector blade. So we will do the same with our blade connector. Apply a little bit more solder to our iron. And I'll typically just apply that directly to the connector. And that's it. You don't have to use too much solder. It's better if you don't, because the solder is not the main conducting material. It's the metal between the connector blade and your wire that is going to be the main conductor. Alright, so now we'll go ahead and set this up so that we can solder both of these together. So the main thing with this connection is that you want the wire to become level and have a good flat connection with the blade. You don't want it to go at an angle like this. You want it to have really good connection, because that's when you're soldering this connector, this is going to be where the power is flowing through, and you don't want any high resistance or limitations on that. So basically for this part, I'll usually just heat up the bottom of the connector and compress that like so. It was very quick. So basically heat up the solder tin that you did on the connector so it becomes liquid again. Then you press the wire down into that, and then you take your iron and you compress, or you place that on the top of the wire, press down slightly until you feel that wire crunch almost, or compress. Once that solder melts, it'll sink through, and voila, there you go. Now again, I'm not the best solderer. I'll admit it. So you could probably do a little bit better job, but that's not too bad. And that's pretty much it. Then what we'll do, this is an important part as well, so we'll take our heat shrink, and then for this, I'll cut this in half. I'll use half on the positive and half on the negative. We'll go ahead, slide this over, and this basically just covers up any exposed wires, and then that will go basically right up to where those little fins on the connector are. You don't want to go up too high, otherwise it could interfere. And for this, if you have a heat gun, you can use that, or a lighter. But also, the base of your soldering iron can be used while you're here. So again, you just kind of rub this all around. I don't use a tip because that could be a little too hot and you could burn it, but the base here will heat that up and compress that nicely. This will slide into the housing. Again, you want to make sure positive is lined up here, and this little raised indent piece is what will catch in the bottom of the connector. So it should kind of press it in, and it should kind of click into place. And if you're having trouble getting it all the way in, sometimes just a little pair of pliers can be used to grip. And once the connector is fully seated, you'll kind of hear a click, and if you notice on the connector, it'll be about that far from the edge. So that is normal inserted connection, and then once it clicks in, it's tight, and it doesn't, like when you pull it, it should not be able to easily come out at all. So if you pull it and it immediately comes out, that means connector is not in all the way, and that is kind of the challenge with these aftermarket TRX connectors, is if you either have too much solder or too much heat shrink perhaps around the bottom of the blade, that it could be interfering. So you might want to check that. So now we shall go ahead and do the same on the negative side. So again, I don't remove the negative wire until positive is firmly in the new connector. Everything's protected, so we don't run the risk of shorting anything. We'll take our snips at the same measurement point and go ahead and cut that. Okay, so now that we have our TRX connector all soldered on, everything is good to go, we can go ahead and use our Traxxas ID charger. And once your charger is on, you will basically go ahead and just plug the negative and positive leads in to one of your charging ports. And this will work with both the single or the dual bank charger. And when you plug your leads in, the negative goes on the right and then the positive goes on the left when you're looking at the charger. And then you will take your balance leads here. Sometimes you just have to twist this around like so, and then you can plug your balance leads in right to the side. There we go. And then you have the 3S, and this is the 2S balance lead connector. So once that's in, you'll notice that the charger will start going up and down red LED, and this will indicate that your battery is connected, ready to be charged. To be able to charge it though, you must hold both the start charge and the charge rate select buttons until it beeps. And then now you can select both your charge type, if you want it to be store, fast, or balance, and you can also set your charge rate. So go ahead and move that up to 3 amps. This is a 6 amp hour battery. Depending on the manufacturer's recommendations, you can choose your different charge settings, but if I'm not in a hurry, I'll usually just do a half C charge rate, which is half of the battery's capacity. And then once your charge rate is selected, you just hold the start button, and then the charger will start charging. It's that simple. So we've successfully converted this battery today to the TRX connector. We'll go ahead and charging it with our Traxxas charger, and we can go ahead and use that in our Slash setup. So I hope this video was helpful for you guys. If you're interested in using aftermarket batteries, again, a simple solution is just purchasing the adapters and using those. However, if you want to, or if you have soldering capabilities, then you can go ahead and solder on your own connectors to make it a permanent solution for you. Hopefully this video helped you. If you guys have any questions, please leave comments below, and then be sure to subscribe if you enjoy the videos and want to tune in for more Slash RC content. See you in the next video.